Create a Python unit test. Unit tests examine independent units of code, like functions, classes, modules, and libraries. There are many reasons for writing a script using Python's unit test library. One obvious reason is that if you find an issue in isolated code by deliberate testing, you know that the problem is in the function or other unit under the test. The problem is not in the larger application that may call this function. You will also know exactly what triggered the error because you wrote the unit test that exposed the issue. Bugs found this way are usually quick and easy to fix, and fixes made at this detailed level are less likely to cause unanticipated side effects later on other code that relies on the tested code. You can run unit tests manually if the code is small, but typically unit tests should be automated. When writing a unit test, think about the following. The unit test should be simple and easy to implement. The unit test should be well documented so it's easy to figure out how to run the test, even after several years. Consider the test methods and inputs from every angle. Test results should be consistent. This is important for the test automation. Test code should work independently of code being tested. If you write tests that need to change program state, capture a state before changing it, and change it back after the test runs. When a test fails, results should be easy to read and clearly point out what is expected and where the issues are. You will explore the unit test framework and use unit tests to test a function. Required resources: one PC with operating system of your choice, VirtualBox or VMware, DevNet Associate Virtual Machine. Launch the DevNet Associate Virtual Machine. Oracle VM VirtualBox. Okay, this is the DevNet Associate Virtual Machine and start. Explore options in the unit test framework. Python provides a unit testing framework called Unit Test as part of the Python standard library. If you are not familiar with this framework, study the Python unit test framework to familiarize yourself. Search for it on the internet to find the documentation at python.org. What unit test class do you use to create an individual unit of testing? The unit test module provides a base class called test case, which may be used to create new test cases. A test runner is responsible for executing tests and providing you with results. A test runner can be a graphical interface, but in this lab you will use the command line to run tests. How does the test runner know which methods are a test? Methods whose names start with the letters test underscore inform the test runner about which methods are tests. What command will list all the command line options for unit tests shown in the following output? Okay. Go to terminal. Python 3, option M for module, unit test, and the H for help. Enter. H is for help, B for verbose, Q for quiet, and other options. The examples: test module, module test class. Other examples: unit test discover. The options: test a Python function with unit test. You will use unit test to test a function that performs a recursive search of a JSON object. The function returns values staged with a given key. Programmers often need to perform this kind of operation on JSON objects returned by API calls. The test will use the three files summarized in the following table. This is the table, the file, three files, recursive, and test data and test search. Okay, for recursive file, this script will include the JSON search function we want to test. For test data, this is the data that JSON search function is searching. And for test search, this is the file you will create to test the JSON search function in the recursive JSON search script. Review the test data file. Open test data file in the lab DevNet source unit test directory and examine its contents. This JSON data is typical of data returned by a call to Cisco's DNA Sender API. The sample data is sufficiently complex to be a good test. For example, it has dict and list types interleaved. Okay, first verify on graphical user interface here on home directory and go to labs DevNet source unit test this directory, the three files, the recursive, test data, and test search. Okay, but on command line, go to and on command line go to labs DevNet source, labs DevNet source. Okay, change directory labs / DevNet source. Press tab to complete enter. Once you are on labs DevNet source directory, use more to view the contents of this file, the test data file, which is placed on unit test directory or subdirectory ls. Okay, to list the contents, and this is the unit test subdirectory, and use more to view in the unit test subdirectory test data.py. enter. Okay, remember, test data, this is the data the JSON search function is searching. Okay, remember that. This is the data. Press a space key, space, space, space. Very good. Create the JSON search function that you will be testing. Our function should expect a key and a JSON object as input parameters, and return a list of matched key-value pairs. Here is the current version of the function that needs to be tested to see if it is working as intended. The purpose of this function is to import the test data first. Then it searches for data that matches the key variables in the test data file. If it finds a match, it will append the matched data to a list. The print function at the end prints the contents for the list for the first variable key1 equal to issue summary. Okay, this is the function. And from module test data, import all, define the JSON search. Our function should expect a key and a JSON object. Okay, this is the key and the object. Okay, this is the function. And finally print the issue summary. Okay, for key number 1, use the function JSON search. Okay, this function. Okay, open the lab DevNet source unit test recursive file. Okay, go to home directory, labs DevNet source unit test. Open this file, the recursive file, and open with Visual Studio Code. So use right click, open with Visual Studio Code. And copy the code above into the file and save it. Copy all this on txt file or any other file, Notepad, for example. Function search, for example. Save. Go to downloads, home directory downloads. This is, and copy all this to here. Okay, very good. Save. Run the code. You should get no errors and output of brackets indicating an empty list. If the JSON search function was coded correctly, which it is not, this would tell you that there is no data with the issue summary key reported by JSON data returned by the Cisco DNA Sender API. In other words, there are no issues to report. Okay, run the file, the recursive file. Okay, run this file, the recursive file. Change directory to unit test. Enter. Use file3 to run the file recursive. Press tab to complete, and this is the file. Enter. Okay, brackets empty. But how do you know that the JSON serve function is working as intended? You could open the test data file and search for the key issue summary as shown below. If you did, you would indeed find that there is an issue. This is a small dataset and a relatively simple recursive search. However, production data and code is rarely this simple. Therefore, testing code is vital to quickly finding and fixing errors in your code. Okay, and search this key, issue summary. Okay, you can review the test data file. You can use more or less to review the test data file. Enter space. This is the key issue summary. Okay, space. Create some unit tests that will test if the function is working as intended. Open the test JSON search file. Okay, here home directory, labs, DevNet source, unit test. Open test JSON search. Open with VS Code. In the first line, import the unit test library. Import unit test. Import unit test. Add lines to import the function you are testing as well as the JSON test data the function uses. Okay, from recursive JSON search, import all, and from test data, import all. From this file, remember this file, recursive JSON search, recursive underscore JSON search, import all, and from test data, import all, enter. Now add the following JSON search test class code to the test JSON search file. The code creates the subclass test case of the unit test framework. The class defines some test methods to be used on the JSON search function in the recursive JSON search script. Notice that each test method begins with test underscore, enabling the unit test framework to discover them automatically. Add the following lines to the bottom of your test JSON search file. Use this. Okay, and copy this to text file. Save. Test 1, 2, 3. Okay, this is downloads, open, copy this, and enter, and here, paste, enter. Very nice. Test JSON search, save. In the unit test code, you are using 3 methods to test the search function. Given an existing key in the JSON object, see if the testing code can find such a key. This is. Given a non-existent key in the JSON object, see if the testing code confirms that no key can be found. This is. Check if our function returns a list, as it should always do. This. To create these tests, the script uses some of the built-in assert methods in the unit test case class to check for conditions. Test case class. The assert true method checks if a condition is true. Okay, this assert true checks if a condition is true. And assert is instance checks if A is an instance of the B type. Okay, this assert is instance. The type used here is list. Okay, list is a list. Also notice that the comments for each method are specified with the triple single quote. Okay, and triple single quote. Comments with triple single quote. Okay, triple single quote. This is required if you want the test to output a description of the test method when it runs. Using the single hash symbol for the comment would not print out the description of a failed test. For the last part of the script, add the unit test main method. This enables running unit tests from the command line. The purpose of ifName main is to make sure that the unit test main method runs only if the script is run directly. If the script is imported into another program, unit test main will not run. For example, you may use a different test runner than unit test to run this test. Okay, add this, enter backspace if okay, and column, enter unit test main, enter. Run the test to see the initial results. Run the test script in its current state to see what results it currently returns. First, you see the empty list. Second, you see the period F period highlighted in the output. A period means a test passed and an F means a test failed. Therefore, the first test passed, the second test failed, and the third test passed. Okay, and run the test JSON search. Okay, don't forget to save. Go to command line interface. Run test JSON search. Test JSON search. Okay, this file. Enter. Okay, and now you will see the brackets and pass, failed, pass, pass, failed, pass. Okay, to list each test and its results, run the script again under the unit test with the verbose option. Notice that you do not need the .py extension for the test JSON search py script. You can see that your test method test search found is failing. Python does not necessarily run your tests in order. Tests are run in alphabetical order based on the test method names. Okay, run the file but use the module unit test with verbose option. Use the module unit test with verbose option, enter. Okay, very good. Now you can list each test. Okay, the first is okay, the second failed, and the third okay. Okay, this should return a list. Okay, key should be found. Return list should not be empty. Fail. Key should not be found. Should return an empty list. Okay. Investigate and correct the first error in the recursive JSON search script. The assertion key should be found, return list should not be empty, fail, indicates that the key was not found. Why? If we look at the text of our recursive function, we see that the statement readval variable is being repeatedly executed each time the function is called. This causes the function to empty the list and lose accumulated results from readval append temp statement, which is adding to the list created by readval. Okay, so readval is being repeatedly executed. Move readval out of our function in recursive JSON search so that the iteration does not override the accumulated list each time. Okay, go to this file, the recursive file. VS Code, go to recursive file, this file, and move this. Okay, very good. Save. Save and run the script. Okay, and recursive JSON search. Enter. And very nice. This is the result. This is the result with the expected content. Run the test again to see if all errors in the script are now fixed. You got some output last time you ran the recursive JSON search. You cannot yet be sure you resolved all errors in the script. Run unit test again without the verbose option to see if the test JSON search returns any errors. Typically, you do not want to use verbose option to minimize console output and make tests run faster. At the start of the log, you can see "F", meaning that the third test failed. Also notice that the list is still printing out. Okay, and run the module unit test with test JSON search without the verbose option. Remove the verbose option. 5.3 module unit test JSON search, enter. Okay, period failed. Period failed. Okay, this is not empty anymore. Open the test data file and search for issue summary, which is the value for key 1. Okay, open this file, test data, with VS Code. Very good. You should find it twice, but only once in the JSON data object. Find key number 1. Okay, key number 1 is issue summary, and find issue summary. This is issue summary key. This is the content. Very nice. And key number 2 is this. Edit, find, trying to find this. And key number 2 does not exist in the data. But if you search for the value of key 2, which is this, you will only find it at the top where it is defined because it is not on the data JSON object. The third test is checking to make sure it is not there. The third test comment states key should be found, should return an empty list. However, the function returned a non-empty list. Investigate and correct the second error in the recursive search script. Review the recursive JSON search code again. Notice that the red val is now a global variable after you fix it in the previous step. This means that its value is preserved across multiple invocations of the JSON search function. This is a good example of why it's bad practice to use global variables within functions. To resolve this issue, wrap the JSON search function with an outer function. Delete your existing JSON search function and replace with the refactored one below. Okay, use this. Go to recursive JSON search. Okay, recursive JSON search. Okay, now you can see this is the JSON search function, but there is an inner function. So this is better. On downloads, here on recursive JSON search file, or very good. Save. Save file and run unit tests on the directory. You don't need the name of the file. This is because the unit test discovery feature will run any local file it finds whose name begins with test. You should get the following output. Notice that all tests now pass and the list for the issue summary key is populated. You can safely delete the print function as it would not normally be used when this test is aggregated with other tests for a larger test run. Okay, and this is the recursive JSON search. Try the following. Okay, try the following. Run Python3 option M unit test, the name of the test underscore JSON search, enter, and no issues. Pass, pass, pass. Also with verbose option. Okay, okay, okay. And also you don't need the verbose option, and also you don't need to specify the file because the discovery feature will find this file that starts with test. Okay, enter. Okay, the same result. Finally, you can on the on recursive JSON search remove the print. Remove the print. Okay, and you can remove the print function because the output can be very long. Okay, so save and run again. This is the print, and here no print. Pass, pass, pass. Okay, very nice. Thank you very much.